Hi there! Welcome to Mathematics Alive Algebra Lesson 23, Solving Equations Involving Radicals. Radical equations are equations which contain a variable inside the radical symbol. Extraneous root. Any value derived by solving an equation and which does not satisfy the equation is called an extraneous root and is therefore excluded from the solution set. Here are the steps in solving a radical equation. Number 1, you have to isolate one radical on one side of the equation. And then square both sides of the equation and solve the resulting equation. Then check whatever values you have before writing the solution set by substituting the derived values in the original equation. So let's have example number 1. 2 square root of y plus 4 minus 8 is equal to 2. Add 8 to both sides so that we'll be able to isolate this expression or this radical. So we have 2 square root of y plus 4 is equal to 2 plus 8. Then we add this 2 plus 8 is equal to 10, and we have 2 square root of y plus 4. And since we have a common factor on both sides, we can divide both sides by 2. So y plus 4, then square root symbol, equals 5. So we have an isolated radical on one side of the equation, then we can square both sides. So we have y plus 4 equals 25. And isolating y is equal to 25 minus 4, or y is equal to 21. Then we have to check the value y against the original equation by substituting y is equal to 21 in the original equation. Checking at y is equal to 21, we have 2 times substituting 21, the square root of 21 plus 4 minus 8 is equal to 2. So I have 21 plus 4 is square root of 25, so the square root of 25 is 5. So we have 2 times 5 minus 8 is equal to 2. So 10 minus 8 is equal to 2, and 2 equals 2. When the left side is equal to the right side, then you are able to satisfy the equation. And therefore, we will accept this value at y is equal to 21. Therefore, the solution set is equal to 21. Let's move on to example number 2. We have 2 square root of y plus 4 minus y is equal to 1. So we have here an expression which is not inside the radical form. So we will isolate this radical by adding y to both sides of the equation. And so we have 2 square root of y plus 4 equals y plus 1. And since this is already isolated, then we can square both sides. So we have 2 squared is equal to 4. Then the square of this, we just simply remove the radical sign because the square and the radical symbol will just cancel because the radical symbol is equal to a power equal to 1/2. So it will cancel with 2. So you have 4 times y plus 2 or y plus 4. Sorry. Equals. So square of a binomial, we have y squared plus 2y plus 1. And then we simplify this. So we will have 4y plus 16 equals y squared plus 2y plus 1. And since we have a y squared here, we will transfer everything to the right side and set the left side of the equation to 0. So we will just subtract 4y and subtract 16 from both sides of the equation. So we have y squared plus 2y minus 4y plus 1 minus 16. 0 is equal to y squared minus 2y and then minus 15. Then we factor this expression. So we have y. Then 15 can be factored as 5 and 3. And we will adopt the negative sign for 5, negative 5, and positive sign for 3. So, solving for the value of y, we have y minus 5 equals 0 or y plus 3 equals 0. Therefore, y is equal to 5 or y is equal to negative 3. These values should be checked against the original equation before we finally decide for the solution set. So, checking at y is equal to 5. So, we will go back to the original equation and then we have 2 square root of 5 plus 4 minus 5 equals 1. So, 5 plus 4 is 9. Square root of 9 is 3. 3 times 2 is 6. 6 minus 5 equals 1. So, 1 equals 1. So, the value 5 satisfies the equation. And therefore, we will accept this value. Next, we have to check at y is equal to negative 3. So, 2 times the square root of y plus 4, you substitute negative 3. So, negative 3 plus 4 minus y. So, you substitute negative 3 for y equals 1. So, 4 minus 3 is 1. Square root of 1 is 1 times 2. So, we have 2. And then, we have negative times negative, positive. So, we have plus 3 equals 1. But this is not equal. And this is in question. So, we have 5 is not equal to 1. And therefore, we have to reject the value y is equal to negative 3. And therefore, the solution set is y is equal to 5. For our example number 3, we have two radicals on one side of the equation. So we have to isolate one radical on one side of the equation by adding this radical to both sides of the equation. I will copy z plus 1, then equals, then I will add square root of z plus 6 to both sides of the equation. So we have isolated one radical on one side of the equation, then we can square both sides. So squaring both sides, we cancel the radical here, and we have z plus 1 equals. Then we will square this, treat this as a binomial. So squaring a binomial, we have this formula, a plus b quantity squared is equal to a squared plus 2ab plus b squared. So this is our a and this is our b. So we first get the square of this. So we have z plus 6. And then 2ab. So we simply multiply this by 2. So plus 2 square root of z plus 6. And then b squared. So you have 1 squared is equal to 1. So our equation still has one radical on the right side. So we will isolate once more. So simplifying this, we have z plus 1 equals, we can add the 6 here and the 1. So we have z plus 7 plus 2 square root of z plus 6. We cannot add the 7 and the 2 here because the 2 here is a multiplier of the radical expression. So do not add the 7 and the 2. So we simply add z to both sides of the equation, or subtract z from both sides of the equation. So we have z minus z, and then plus, we also subtract 7 from both sides of the equation, plus 1 minus 7, so this becomes 0, plus 2 square root of z plus 6. So z is 0 here, and then negative 6. Negative 6 equals 2 square root of z plus 6. And since we can divide both sides by 2 to simplify the equation, then we divide both sides by 2. Cancel. 6. So you have negative 3 equals square root of z plus 6. And once again, we will square both sides because this expression, the radical expression, is already isolated on one side of the equation. So we square this, and then cancel this, So we have 9 equals z plus 6. And then isolate the variable on one side of the equation. We subtract 6 from both sides. 9 minus 6 equals z. Therefore, z is equal to 3. And then we have to check the value at z is equal to 3. And we will go back to the original equation. The square root of z plus 1, substitute 3, minus the square root of z plus 6, substitute 3, again for z, equals 1. 3 plus 1 is 4, square root of 4 is 2. 3 plus 6 is 9, square root of 9 is 3, equals 1. But we get here a negative 1, which is not equal to 1. So this is questionable. So we reject the value z equals 3. And since we have rejected the one and only solution, then there is no solution to the problem. Your solution set is empty. There is no real solution to this problem. For our example number 4, we have a radical embedded inside a radical symbol. We will treat this as one radical expression. So it's already isolated on one side of the equation, so we can directly square both sides. And we can cancel the radical here. So we have 3 plus the square root of 8 minus y is equal to 4. Then we will isolate this radical on one side of the equation by subtracting 3 from both sides. So we have square root of 8 minus y is equal to 4 minus 3, and that's equal to 1. Square root of 8 minus y. And we can, once again, square both sides. So squaring both sides, we have 8 minus y is equal to 1. And we have negative y is equal to 1 minus 8. So negative y is equal to negative 7. So when the variable is negative, then you simply multiply both sides by negative 1. And this becomes positive. Y equals 7. Then check the value of y against the original equation. Three plus the square root of 8 minus 7 equals 2. So square root of 3, 8 minus 7 is 1, square root of 1 is 1, plus 1 equals 2. So square root of 4 is equal to 2, 2 is equal to 2. So the value satisfies our equation, and therefore we will accept this value, and the solution set is y equals 7. don't make a mistake of making this the solution set, because some students, when they find out that there are equal expressions or equal numbers on both sides of the equation, they pick up this number and put it in the solution set, and that is wrong. So our solution set should be the value that we substituted in the original equation. And that's all for our examples for radicals. And you have to do a lot of practice now in order to be able to master this skill in solving equations involving radicals. So if this had been helpful to you, please like, share, and subscribe to this channel by clicking the button below. Thanks for watching, and bye-bye.